Okay, now let's shift gears talking about goods and services, and now we're going to talk about production and productivity. Like we talked about a couple slides ago, that in the operations management overview, that production is the creation of goods and services. And the production of goods and services requires transforming inputs into outputs. That process of transforming inputs into outputs is called the feedback loop. Okay, the feedback loop. So we're taking those inputs, we're putting value into them, we're transforming them, and they're becoming an output, and that is the feedback loop. The operations manager's job is to improve that transformation process, making the team more productive, making them more efficient, and therefore able to increase our productivity because we're making the team more efficient and more productive. This feedback loop of taking inputs and transforming them into outputs, in America, we improve our annual productivity by about 2.5% per year. And compared to the rest of the world, that's pretty good. Some nations do a little bit better, maybe a couple percent more, but most are pretty stagnant in the 0 to 1% range, improving productivity. So 2.5%, we're going to talk about the three different ways in which we improve productivity through labor, capital, and management in the next couple slides. But America improves that transformation process by about 2.5% per year. Now, one thing to point out about improving productivity in that transformation process, it can be done one of three ways. The first one is to decrease the amount of inputs while holding your outputs steady. So if you decrease your inputs and hold your outputs steady, you're improving productivity. You're becoming more efficient, and therefore you are improving your productivity. You can also increase your outputs while holding your inputs constant or keeping them steady. So if you keep your inputs steady and you increase your productivity and you increase your outputs, you there become more productive. And then the best case scenario is to reduce inputs while also increasing your outputs. So reducing your inputs and increasing your outputs, and that's going to improve productivity even more. So the productivity variables that we're going to discuss are labor, and that contributes to about 10% of the annual increase per year. And if you think about, employees and your labor workforce, employees can only work so hard. Eventually, they're going to make mistakes. They're going to need to go home, right? And they need to eat and they need to take bathroom breaks. So employees can only work so hard before productivity starts to decrease and quality starts to decrease as well. Well, you've heard the old adage before that you need to work smarter, not harder. Well, strategic improvements increase productivity more than working harder. So you can see now, here's a picture of some capital equipment that was purchased, and that improves productivity by about 38% per year. So you can see in the picture up on the screen, there is someone who is doing hand soldering. They're putting resistors and capacitors onto a printed circuit board, and they're doing it by hand. They can only go so fast before they start to make mistakes. Well, the picture underneath that is a printed circuit board assembly machine. I've seen these before. They're millions of dollars, sometimes pieces of equipment, but they can work 24 hours a day, 7 days a week, even on holidays, and they just plug away, putting resistors, capacitors, and electronic components on these printed circuit board assemblies, and they don't make mistakes, and they don't get tired. So capital can help to improve that productivity by 38%. Now, you may be thinking to yourself right about now, well, he said management. How can management be the rest of that 100%? How can they contribute to about 52% of the annual increase every year? And that's because management's going to incorporate lean initiatives, organizational restructures, looking at process improvements. These are all of the things that you as a manager will be responsible for incorporating to improve productivity when you oversee either a service or a goods producing facility. No matter what, you can find different management ways to improve productivity. So let me give a really quick example of what that would look like in a sandwich shop. So let's say you go to Subway Sandwich and you're going to order a sandwich from them, a ham sandwich. And the person starts to make your sandwich. They take the ham and they cut it by hand with a knife. Okay? That employee can only work so fast every year before they start to either make mistakes or have a physical accident using that knife. Okay, they can only improve productivity by so much. So if me, the manager of that Subway shop, say, how can I improve productivity a little bit more? Hey, well, maybe I go out and I buy one of these specialty meat grinders to get the ham cut even faster. So my employee can now take the ham, stick it on the grinder, and that'll slice this ham even faster. So that'll work, and that'll improve productivity by about 38% per year. But I can do things, I can improve productivity as a manager even more. I could just buy the ham pre-cut. And so therefore my employees never cutting something by hand and potentially hurting themselves. I don't have to go spend all the money on the expensive capital equipment. I can just buy ham pre-cut, and that's going to make my employees more productive because now they no longer have to slice any of the ham every time they make a sandwich. So productivity. Again, we already talked about the various ways you can improve productivity through inputs and outputs on the very first slide, but productivity is a measure of the effective use of resources expressed as the ratio of output of a process to the input. The objective is to improve productivity by improving that ratio. The formula is productivity equals the units produced divided by the inputs used. So whether we're improving the amount of outputs that we have per year or decreasing the amount of inputs that we've got to improve that productivity ratio, we want to try and make our team more efficient, more lean, and more productive. And so efficiency is doing the job well with a minimum of resources and waste, and improving productivity improves efficiency. We're going to go over various methods for improving productivity, being more efficient, finding ways to cut out waste and be more lean on Chapter 16, which is on lean manufacturing. Because when you become in management and you are in charge of that sandwich shop, not everything's going to be intuitive on the ways that you can improve that productivity. There are various tricks and tools that you can use to find quantifiable ways to improve that productivity. So productivity ratios are used for planning workforce requirements. So are my employees becoming more productive or less productive? And how do I want to schedule them accordingly? Scheduling equipment, does it need maintenance or is it running efficiently and smoothly? And then financial analysis. Again, are my employees, is something happening where they're becoming less efficient and that therefore I need to hire more and I need to plan for more financial capital to pay for more people or more equipment. So these ratios help for all of productivity, workforce planning, scheduling equipment, and financial analysis. All right, so productivity. Productivity is a relative measure. It can be compared with similar operations within its industry, and it can be compared over time. So if I'm a manufacturer of computers, I can look at productivity for my company, Dell, versus HP or Apple to see how productive they are building their computers. And it will tell me, oh my gosh, I know that Apple has a whole bunch more capital equipment than they do, and they're a whole lot more productive. Maybe we need to go that route. Maybe we need to buy more capital equipment and have less manual labor, building our computers. Whatever it may be. They can be compared with similar operations within the industry, and you can use that for benchmarking purposes. Well, productivity can be expressed as a partial measure, which is the outputs to one input. Okay, the outputs to one input. That can also be called single factor productivity. I historically call it single factor productivity because you're looking at a single factor. You're looking at output versus labor, or output versus machinery, or output versus your capital equipment. All of those help us to gauge how we are doing on a partial measure or a single factor to see, have my people become more efficient? Have they become more productive? Or are they starting to slip in their productivity? Another very useful measure would be the multi-factor productivity. And that's when you look at an output to a group of inputs, okay, a group of inputs. So labor and machinery versus my output. This one's very useful because, again, let's go back to a manufacturing facility. I've got hundreds of people who are building products and I've got millions of dollars of capital equipment. If I'm going to spend all that money on capital equipment, I want to make sure that my outputs are being increased and that my productivity is getting better. Okay, we're trying to improve that productivity ratio. So multi-factor measures help us to determine that when you're comparing a group of inputs to see how it's comparing for productivity. So you're adding labor plus machinery, or labor plus capital plus energy, whatever it may be, whatever you determine as your multi-factors. Multi-factor measures look at an output to a group of inputs. The last measure of productivity is total measures. And this is where you're taking the output, so your total output, versus all of your inputs. So all of the inputs that are used to produce them, it could be material, labor, machinery, capital, energy, whatever it may be. And that's just looking to see if my total output and my total productivity has been improved by looking at every single thing that we measure, all of our inputs, versus a group like multifactor or a single or partial measure where we're just looking at things on, say, one-for-one basis. All right, productivity growth is the increase in productivity from one period to the next relative to the productivity of the previous period. Okay, so productivity growth is looking at productivity from a previous period to our current period. Now, productivity can also decline. So you can see in parentheses I've got their productivity growth or decline is the increase or the decrease in productivity from one period to the next. Okay, so just keep in mind productivity can go the wrong direction and productivity can decrease or decline as well. Our productivity growth formula is current productivity minus previous productivity divided by previous productivity multiplied by 100%. Okay, so that's our formula for productivity growth. And you will see this on most of your quizzes and or exams. So as an example, and I've left the blank on Canvas for you to fill out. What is the growth rate if productivity increases from 80 to 84%? Okay, what is the growth rate if productivity increased from 80 to 84? What is the percent growth? So I'm going to give you just 20 seconds here because this is a very simple formula. You've got the blank space, and we want to determine what the productivity growth is if we went from 80 to 84 outputs. Okay, this one's pretty straightforward. We're taking 84, which was our current productivity. We're subtracting 80, which was the previous productivity. We're dividing it by 80, which was the previous productivity. And we're multiplying it by 100%, and that gives us a 5% productivity growth. Okay, let's do a little harder example now. So consider a division of Miller Chemicals that produces water purification crystals for swimming pools. The major inputs used in the production process are labor, raw material, and energy. So there's 3 different inputs. For 2019, your labor costs are $180,000, raw material costs are $30,000, and energy costs are $5,000. For 2020, your labor costs are $350,000, raw material costs are $40,000, and energy costs are $6,000. Miller Chemicals produced 100 pounds of crystals, 100,000 pounds of crystals in 2019, and 150,000 pounds of crystals in 2020. So the question is, has productivity increased or declined between 2019 and 2020? Okay, a couple things I want to point out here real quick before we even get into this example. When we ask, has productivity increased or declined between 2019 and 2020, you don't know yet. Okay, you've produced more chemicals. Okay, you're now producing 150,000 pounds versus 100,000 pounds, so you're producing more. But we don't know if we've been more productive. Okay, so just keep that in mind. The other thing to notice with this question is that there are 3 inputs. So this is multi-factor productivity, not single-factor productivity when doing this equation. Okay, so for when you're doing your exam, if I were you, I'd put them in nice little bullet points like this, comparing 2019 versus 2020. You've got your labor, your raw materials, and your energy, and then your total output of crystals in pounds, which is in 2019 there was 100,000, versus 2020 there was 150,000. So all we are doing is we're going to take the quantity of our output divided by the quantity of input, and you're going to do it for both years. So first you're going to do 2019. So you've got 100,000 crystals, 100,000 pounds of crystals. That's your output. And you're going to divide it by your 3 inputs, which is $180,000 of labor, $30,000 of raw materials, and $5,000 of energy. You're going to add all of those up. And when you do $100,000 or 100,000 output, your output of 100,000 units, divided by those 3 inputs, you're going to get your productivity ratio of 0.465 pounds per dollar. So that's for 2019. Now let's do 2020. So your productivity is you produced 150,000 pounds. Your inputs are $350,000 of labor, $40,000 of raw materials, and $6,000 of energy. So when you add all of those up and you calculate the productivity ratio, you're at $0.379 per pound. So you're not done yet, because we're asking for the change in productivity, not just the productivity for 2019 or productivity for 2020. So productivity dropped because your productivity for 2020, which was your current productivity, is 0.379. Your previous productivity was 0.465. So when you do that calculation, you get to a negative 18.49% productivity. So productivity got worse, even though your production was higher. Now, if I'm the manager of this facility, I look at all this data and I say, ooh, what went wrong, right? My raw material costs went up accordingly, right? We went from $30,000 to $40,000. My energy costs went up accordingly, $5,000 to $6,000. My output went from 100,000 pounds to 150,000 pounds. What went wrong? Well, it's clearly labor. Labor almost doubled from $180,000 a year to $350,000 a year. So your labor almost doubled, and that threw off your productivity improvement, and that's what made it such a big decline. Now, as a manager, you're going to look at this and you're going to say, why? So in this example, maybe that productivity going from the production of 150,000 crystals was hard, and you had to hire all these new employees and they weren't well trained and you had to work overtime, and that's why your labor costs went up so dramatically. These are the things you got to figure out as a manager. But in this instance, your productivity was lower by 18.5% from 2019 to 2020, even though you produced more. Okay, so here's a real-life example of productivity at Starbucks. A team of 10 analysts they look for ways to shave time. So they're Lean Six Sigma folks. They're going into these facilities to try and find ways to make improvements. And so over the years, a couple of the things that they determined that would improve productivity were, one, let's stop asking for credit card signatures on any purchase under $25. And that shaved 8 seconds off per transaction. They changed the size of the ice scoop, and that saved 14 seconds per drink. I remember when they did that, because I remember back in the day, they would scoop multiple times to get a venti in there. And then now, if you notice, they've got one for the tall, the grande, and the venti. They've got different size ice scoops. So they go in once, boom, they're done, and then they move on. And then new espresso machines helped them to save 12 seconds per shot. So these are just a couple seconds here and there, but a couple seconds matter when it comes to improving productivity and how that translates to the bottom line. Starbucks increased their yearly revenue and productivity by $250,000 per year. That helped them improve by about 27% over the course of 7 years, which they determined was about 4.5% productivity improvement per year. And by doing some of these improvements and other little ones to help them keep up with the high volume of demand that people that request their services, like me. I love Starbucks coffee. So I'm constantly looking at them and ways which they can improve productivity. So some of these were very welcome additions to me. All right, now let's talk about service productivity. Productivity in the manufacturing sector is a little easier to improve because you can really work on a lot of different process improvements. You can get that capital equipment, which can be a 38% productivity improvement. So there's lots you can do in the manufacturing sector to help improve manufacturing productivity. In the service sector, it's a little more difficult, mainly because it's typically labor intensive. We frequently focus on unique individual attributes or desires. It's often done by an intellectual task performed by professionals. It's hard and difficult to mechanize, and it's often difficult to evaluate for quality. So these are all the reasons why it's harder to improve service productivity than it is manufacturing productivity. So let me just give a real quick example of what this looks like. So if you think about getting your hair cut, it's labor intensive. Someone is manually cutting your hair. It's frequently focused on unique individual attributes or desires. Every person that walks in that facility wants a different haircut or different style. They have different attributes or desires. So every output is different. It's a task performed by professionals. Absolutely. These people have gone to schooling to get certifications, to learn how to cut hair so that they can be productive and do a good job. and it's often difficult to mechanize, right? So when you go to get your haircut, you're going to someone because you want those services. You're not going to just stick your head under a Flowbee or some other kind of piece of equipment to cut your hair. So these are all reasons why it's harder to improve service productivity versus manufacturing productivity. Okay, so we are done with this lecture recording. We've talked about productivity and the productivity ratio. We've gone over single factor productivity, multi-factor productivity, and all of the total factor productivity. And you will see these formulas on your quizzes and your exams looking at whether productivity has improved or whether productivity has gotten worse and declined.